Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 3 of AI Assisted DevOps Zero to Hero series. In the first episode, we learned about the fundamentals of Gen AI. In the second episode, we focused on prompt engineering and various prompt engineering techniques. In today's video, I will show you how you can create your very first generative AI project as DevOps engineers. So imagine as a DevOps engineer, you develop a Python script, and this Python script is used by the developers where if developer provides input as Java, then the Python script generates a Java based Docker file. That is Dockerfile for Java-based applications. Similarly, if other developer provides Rust as input, then the same Python script can generate the Docker file, but this time for Rust-based applications. Or even a developer provides programming language like Ruby on Rails, which is not quite common as Java, but still the Python script that you have written can generate the Docker file for Ruby on Rails. Wouldn't that be amazing? Definitely yes. And that is what we are going to create in today's video. I will show you how you can set up this entire project, and the Python script that we are going to write is powered by Gen AI. That's why it can create Docker file for any programming language. I'm sure it's going to be very interesting. So make sure you watch it till the end. And to make it simple, a lot of you might want to try this project. So that's why if you go to this repository and go to Day-3 folder, you will already find the content, how to set up this project, what commands to run, all the instructions that you find useful. And the Python script is also shared in these folders. There are two different ways how we are going to implement this project using local LLMs and hosted LLMs. Both of them, I mean, the Python script related to both of them is already shared in the Git repo. Just start this repo so that any changes made to the repo, you get the notifications. Let's get started. So the first question you might have is, Abhishek, why should I create this project? Like, I can simply go to ChatGPT and ask ChatGPT to create an ideal Docker file for Java-based application. And if required, you can also provide some constraints like the port that you need or any specific constraints that you have. And yeah, definitely ChatGPT provides you the Docker file. But as I told you in previous videos, the Docker file that you get here or ChatGPT is something that is only for your learning purpose. This is not something that you can automate, right? And in a lot of companies, access to these chat assistants or access to these chatbots is also denied. So in a lot of MNCs today, you cannot access ChatGPT or equivalent chatbots. So every time a developer coming here or they don't have access is not that smooth experience. So what you can do is you can automate this process. Now, how you can do it? If you remember our previous lectures, I explained you about large language models. Even ChatGPT here is using a large language model that is provided by OpenAI. Similarly, there are thousands of large language models out there. So by making use of these large language models in our Python script, we will automate this experience for the developers. Now, large language models are broadly divided into two categories. One is local LLMs, and second is hosted large language models. What are these? I'll explain in very simple words. There are companies like Meta. So you might be knowing Meta, the one that is the creator of Facebook and apps like Instagram. So Meta also developed their large language model. So large language model is nothing but a Gen AI model which is focusing on text-based generation. So Meta also has their large language model which is called Llama, and anybody can download these large language model and run them on their local machines. Of course, there are some steps needed, which I'll talk about. But Meta has put their model out there, and anybody can download this model and run the model on their machine. Similarly, DeepSeek as well. You can actually download the DeepSeek R model and you can run it on your machine. IBM also has something called Granite, where you can download this model and run this model on your local machine. So that's why these models are called as local large language models. Now there is second category called hosted large language models, where, for example, companies like OpenAI. So what they have done is they have set up infrastructure. So OpenAI has built a lot of data centers where they set up their servers, they have the GPUs on those servers, and those servers have the large language models of OpenAI. So what they do is that they allow developers or DevOps engineers to create API key, just like how you create API key with GitHub to talk to GitHub, how you create access key with AWS to talk to AWS. Similarly, OpenAI also has API key, which you can create, and using that API key, let's say you're writing a Python program, you can use that API key in your Python program and you can talk to the hosted large language models of OpenAI. DeepSeek also has hosted large language models. They have local and they also have hosted large language model. Similarly, Google has Gemini. A lot of companies also have these hosted large language models. Because they are hosted on the environment of these companies, we call them as hosted LLMs or remote LLMs. Now, you might ask, Abhishek, which approach should I take? Like in this case, we are building the project where we will write the Python script and we will use generative AI. But should I take the local LLMs approach or should I take the hosted LLMs approach? Of course, in this video, I'm going to show you both the approaches. That is, we are going to implement Python script in both the cases. However, let me explain you pros and cons of both the approaches. If you're going for local LLMs, the biggest advantage that you get is security. Imagine that large language model is running within your organizational servers or within the data center of your organization. Although it is developed by Meta, but you are downloading it and you are running it on your servers. So there is a lot of security and privacy that you get. Meta does not have control of the questions that you are asking to that large language model, or Meta does not have control on your data. So it's a great advantage with respect to privacy and security. However, there is a downside as well. That is infrastructure maintenance. For your personal use case, you might run this large language model on your laptop. Now that's totally fine. But when you want to scale this for your entire organization, imagine you write thousands of these Python scripts and you share these Python scripts with the developers. You have automated all the use cases and now you share that with your developers. And you have thousands of developers, assume all of them are trying to access this large language model. Now the challenge is that you have to set up the whole infrastructure so that your large language model can run. Now we are talking about 1,000 developers. accessing that large language model. So you have to create multiple copies of it, or you create one copy with enough resources. That means you are ending up building a data center or creating bunch of servers. And these servers needs maintenance, just like any servers, right? You have to continuously update them. You have to patch them, just like a virtual machine. If you go to cloud provider, like if you take the same example, right? Private cloud, public cloud in the world of DevOps, so that you people can understand better. You can also buy a physical server today from HP or IBM, and you can run your applications on the private servers or the physical servers. But why most of the people are using public servers, the AWS platform, Azure platform, or GCP platform? Because they don't have to set up the infrastructure, they don't have to maintain it. Although you get more security in the private physical servers. Saying that, there are also disadvantages of hosted LLMs. The disadvantage of hosted LLMs is that security and privacy. Just like how we asked question to the ChatGPT here, imagine one of your developers has the API key of OpenAI, and developer is asking question to OpenAI, but probably developer is sending some important information to OpenAI. Right? You don't have control, right? Today, if you have ChatGPT, let's say you have ChatGPT here, and it is open in your organization, you have no control. You might train your developers, you might say uh, your developers to do a course, but still, what if developer copies the code here? Developer takes 10 lines of code and asks ChatGPT to optimize the code. The fun fact is that ChatGPT not only responds back, but it also use the information that is provided by the developer for its training purpose. And that information might be shared with someone else. So there is huge risk with respect to security when you are dealing with hosted LLMs. Of course, the positive side is that you don't have to bother about the infrastructure. And another downside is that the hosted LLMs, if you use the API key of OpenAI, they are going to cost you. Just like AWS costs you, right? For using their resources. Similarly, if you are making API call to the LLMs hosted by OpenAI, Google, or anybody, they are actually going to cost you per API call. Exactly what I explained in previous video, right? In day 2, I said there is something called tokens. So tokens is the combination of input prompt that you provide and output. So what usually LLMs do, or these companies do, is that they count the combination of input output words. Overall, let's say if the input and output comes to 1,000 words. So these 1,000 words has a particular costing. These 1,000 words might come to 600, 700 tokens. And per tokens, the cloud providers, sorry, in this case, the LLMs providers, they will cost you. So in a nutshell, even if you don't understand this at this point of time, just, just think of this way. Whenever you are making API calls with the hosted LLMs, they are going to charge you per API call. And if the text is more, the response that is coming from the LLMs is more, that is you are costed more. Now, depending upon your organization, you can take the call. Now, if your organization is bothered more about security, they should consider local LLMs. If your organization is bothered more about maintenance, that is, who is going to maintain the infrastructure, who is going to maintain the GPUs, we need data center, we don't have enough resources for the data center, then your organization should go for hosted LLMs. Now, saying all this, assuming you understood local LLMs, hosted LLMs, let's start with local LLMs. That is, how can we implement this project using local large language models? Again, if anybody is confused, LLMs is large language model. Basically, in generative AI, any model that is dealing with text is called as LLM. Okay, Abhishek, how can I start with local large language models? So basically, you can download these models. Okay. And to download these models, there is something called Olama. So Olama, because most of the people are DevOps engineers, can be compared with Docker for multiple reasons. Just like how you have Docker Hub for Docker, where all the images are hosted. Similarly, Olama also has a website where all the models are hosted. Just like how Docker has a CLI, which is used to pull the images, run the images from Docker Hub. Olama also has a CLI, which is used to pull the models and run the models on your local machine. Let me show you how. So just go to olama.com, https olama.com, and this is just like Docker Hub, where you can search for any model. Let's search for Llama model from Meta. So Meta has popular models like 3.2 and 3.3. 3.3 is their latest model. Let's go with 3.2 because in 3.2 they have a smaller version of their LLM that is with 1 billion parameters. So whenever you see billion parameters, like when you see, let's say 400 billion parameters, that means the model is trained on huge amount of data. When you see 1 billion parameters, comparatively, the model is trained on less amount of data. That's why the size of the model and performance of the model is little less. Scroll down and click on 1B. You get the command here. Just go to your terminal. Okay. Irrespective of you're using Windows, Linux, or Mac, just go to your terminal, run this command. Obviously, it says Olama not found because we got access to the Olama hub where the models are there, but we don't have the Olama CLI yet. Go to the Olama homepage. For Windows and Mac, it's very simple. The approach is very same, where just like you have Docker desktop, they have a web version of Olama. For example, if I click on Mac OS and click on the download button, it downloads a DMG. And when I click on that DMG, it starts the Olama and it provides the instructions on how can I download Olama CLI. Same is with Windows as well. But if you're using Linux, it's little different. You get a curl command. Just copy the curl command, install Olama, and then you need to run Olama serve. Abhishek, where can I find them? Don't worry, go to our GitHub repository. If you are using a Linux machine, go to the README file. And here I already shared the instructions. Using the curl command, just install Olama and start Olama using Olama serve command. And then you can pull any model, just like you use Docker pull command, you can pull any model that you are looking for. If you're using Mac or Windows, you will just not use this particular step because it is already started just like your Docker desktop. Even if you want to use it, you can do it, but it is already started once it's installed. Let me show that to you. Let's go to the downloads and double click on the DMG. So it says move to the applications. I'm totally fine because I'm going to use it every day. And you have this wizard page, web interface page, whatever you would like to call. Not a web interface page, but a small wizard where click on the next. It says, should I install Olama CLI? Just like you need Docker CLI. I will say install, go ahead. And these are my credentials. and then it provides the command to run Olama. However, I don't want to run the model. I just want to pull the model. So what I'll do is I'll go back to my terminal. Okay. And I'll first verify if Olama is started. Olama basically Olama help. And I will just see if Olama is started using Olama serve or Olama start command. Both are same. If I do Olama serve and if I see this address already in use, that is Olama is already started. In your case, if you don't do that, if you don't see that, just do Olama serve and it should get started. Now, once we have Olama CLI, like I said you, just go back to the model that we are looking at. Llama 3.2 is what I'm looking at, 1 billion parameters. And I'll just copy this command. I don't want to run the model, but I just want to pull the model. What is the difference? If you run the model, it is just like running the Docker image directly. So, no, you got, of course, it will take a couple of minutes in your case. I'm using a 28 GPU machine. So all the things that I do are pretty fast, but on your machine, every instruction that you're seeing here might take a couple of minutes. So please be patient because you might be using a CPU architecture machine. In my case, I have like 28 GPUs, so it's super fast. Okay, so it's just like running the Docker image. So Olama run Llama 3, that means now I have a large language model downloaded on my machine and it is already running on my machine. So I can basically ask, create a Docker file for Java based app. Again, this might take even 5 minutes on your machine. So if it is taking time, please be patient. So you can see here, it generated the Docker file for Java based application and it is also giving me the instructions that what exactly is the generated Docker file. But we want to automate this through the script, right? We don't want a command line experience. That's why what I'll do is I'll just stop the model and Olama pull. It's already pulled, but still Llama 3.2. So it pulled the manifest, 100% pull is complete. So our step one is done. What is our first step? Is to download a large language model on our machine. Second step is to set up the Python environment. Let's write down the steps. Step one is to install Olama. What are these steps for? These steps are for the local large language models. Step one is to install Olama. Step two, identify the large language model that we need. Step three is to pull the large language model, which we did. Now, step four is to set up Python environment. Then step five is to write the Python script. Abhishek, what should I set up in the Python environment? Very simple. First, verify if you have Python on your machine. I assume a lot of you might have Python. If you don't have, just go to internet search, install Python. Very simple task. Once you have Python on your machine, do not directly jump onto installing the prerequisites. It's always a best practice to set up virtual environment. So what is a virtual environment? If you know Python, so basically it's a isolation within the same machine. When you are trying to run multiple projects, you can do logical isolation of packages using virtual environment. Two developers are working on same machine, or you are working on two different projects. And one project, let's say, is using Ansible X version, and other project needs a dependency of Ansible Y version. Now you cannot have both Ansible X and Y at the same time active. So what you can do is you can use virtual machine concept, uh, virtual environment concept, where the packages that you download for a particular project will be isolated from the other things. I have explained all of these concepts in our Python for DevOps playlist. In case you did not watch it, for now, just understand you need a virtual environment. Okay, so this is the command to install virtual environment. Then we will source the virtual environment using this command. Source VNV is the name of my virtual machine. Bin activate. Okay, the files will still be the same. I already cloned the repository and I'm within this repository where I have the files that you see in the GitHub repo, right? The day-3 repo, whatever the files you see here is already cloned on my machine. What after that? Like once you have installed the virtual machine, sorry, virtual environment, I keep saying virtual machine, my bad. Then you have to download the dependencies, right? Before you write the Python script, always you should download the dependencies. What are the dependencies? Very simple. By now, you might have understood that to interact with the large language models, what am I using? I'm using Olama. Can I directly talk to large language model on my machine? No. I need Olama CLI or I need the Olama package. Similarly, in your Python script also, the dependency that you have is Olama. Why? Although you have large language model on your laptop, it's just like a zip file or it's just like a package. You cannot directly talk to this. You have Olama as an interface where you can talk to Olama's CLI or Olama's API, and that will in turn talk to the model. Let me show you a representation here. So you are a user. What you are doing is you are going to write a Python script. Okay. Within this Python script, you will use Olama package, right? And using the Olama package, you will talk to Olama API that is installed on your machine, right? You installed Olama on your machine, right? So that Olama has both API and CLI. So within your Python program, you will use the Olama package. That package will talk to Olama API and that will talk to the large language model. You cannot directly talk from your Python program to the LLM. That's why. Okay, so we need a requirements.txt file. I have two different folders here. One folder is for local large language models. And here you will clearly find there is a requirements.txt file. And that requirements.txt file just has Olama, right? Vim requirements.txt, you will just find Olama. So what we need to do? Pip. Of course, if you don't have pip on your machine, you need to install pip. So you can just do brew install pip if you're on Mac, or if you're on different operating system, just search for installing Python pip. I'll also try to put the details in the description so that if anybody is not good at Python, they can understand it. pip3 install requirements.txt. So now it will download the package. Which package is this downloading? Olama package. Okay. Why is it downloading the Olama package? Your Python script cannot directly talk to LLMs. It should talk to Olama that is installed on your machine. To talk to Olama installed on your machine, Python needs a package, right? So the Python program needs a package. That's why we are using Olama package. Just like how we use, for very simple example, as a user, let's say you want to access environment variable from your machine. Okay, this is your laptop. And if your laptop has a environment variable, to access it in your Python program, you use OS package or sys package, right? Using these packages only, you can actually fetch the environment variable on your machine. You cannot directly fetch that using Python program. So the same thing. To interact with Ollama API, we are using Ollama package. I'm just repeating things here because a lot of people, okay, I think I used the wrong command. Pip install -r requirements.txt. A lot of people might be new to Ollama, LLMs. So that's why I'm repeating so that they will start finding this terminology familiar. Okay, so it is taking little time. Let's wait for it to install the package. Cool. So after, I think, couple of minutes, the package is downloaded. So now we can go to our actual script. That is, we can start writing our actual Python script, which is generate dockerfile.py. It's a very simple file. If I do set number, you will see that it is hardly a 20 lines Python program, right? There are a lot of spaces here. If you ignore that, and this is all the prompt. So it is hardly, this is a program. That's it. And that is also, I created method, that is I created a definition and I followed the best practices. Otherwise, this Python program is just a 5 to 10 lines program. I'm going to explain you what exactly we are doing in this, and then I will explain the code point of view. So first step, what we have to do is, obviously, within the Python program, we import the packages. In any programming language, the first thing that you do is import the packages. In this case, we will import Ollama package. Perfect. So once we imported the Ollama package, we will prepare the prompt, right? And our prompt is going to be multiple lines. It will not be a single line. So we will use 3 double quotes, and within the double quotes, we will write our prompt because it's going to be a multi-line prompt. When you use 3 double quotes, so everything that you write between that 3 double quotes is considered as a comment, and that basically we are using here is a multi-line string, because our prompts are usually multi-line strings. We are going to provide as detailed prompt as possible, and we are also going to provide the constraints if required. We are going to provide the context if required. We are going to provide some examples as we learned in previous video, that is few short prompting. Okay, first we import the package, then we write the prompt, and then we can actually write the API call. Okay. However, to follow the best practices, because you might use this in your organization, you might improvise it and use. So what I'm going to do is I'm going to write a function. The function will be called as generate. In Python, how do you write a function? You just start with the def keyword. So we will use it as generate dockerfile, and we need an input to this function, right? So what is the input? The language of the programming. It should be Java or Node.js or Ruby on Rails, Groovy or something. And using this symbol, right, colon. So you will basically say that the function declaration, this is the function declaration, and then you can start writing the code. That is the API call. So what will be the API call for talking to the Ollama? Very simple. You already use the Ollama package. So you can simply say Ollama dot chat, and within the chat you will provide couple of things within the chat. One is, what is the model? In our case, model is llama 3.2 colon 1b, then comma. Within the comma, you will just provide the message. I mean, after the comma, you provide the message where you will define what is the role, and then you will provide the content. What is the content? Basically, you will provide the prompt. That's it. For any program that you write going ahead, this is what you are going to write. You will create a definition, and this is the API call. This output of this API call, you will read within a variable called response. So response is equals to this. And then whoever is calling this function, you will return what you will return. You will return the response. Return response, because response is going to be a JSON. So you will just say message, and within the message, you are going to respond with content. That's it. If you just return the response, what you will see is you will see a JSON with lot of information. So from that, I'm taking the message field, and within the message field, I'm taking the content field, so that I just get the Docker file. And after this, because this is just a function, somebody needs to invoke this function. So I'm going to invoke this function, where we will just write the standard if underscore underscore name is equals to underscore underscore main. I explained in our Python playlist why we use this particular thing. I mean, now it's out of context, but basically it is important when we, for the Python compiler to explain, is it a package or is it part of the main program that you are writing. But for now, just understand that you write this as a good practice, and within that we ask user input. So we will ask user to input the programming language that user is interested, and then we invoke the function print. I mean, I'm invoking the function within the print so that output is directly print on the screen. Print generate, what is the name? Generate underscore Docker file and language. Language is the variable or the input that is provided by the user. That's it. This is the program. Now you can also find it here. First, we start with import Olama. Then this is our prompt, as I explained you. What is the prompt that you are using in the Python program? Only generate an ideal Docker file for language that is provided by the user with best practices. Do not provide any description, because I just need the Docker file. I don't need explanation of the Docker file or anything. And this is the constraint that I'm providing. Again, in previous lecture, I explained what is constraint, what is context, what is few short prompt engineering with examples. So here we are providing constraint, where I'm saying, make sure you include base image, you include installing dependencies, you include setting up work directory, adding source code, running the application. Let's say you want to improvise it and you want to create a multi-stage Docker file. So you can also say multi-stage distroless Docker image. You can also say expose port, right? You can add more number of constraints. However, my intention is to just show you the light version of the Docker file. As an assignment, you can improvise the Docker file. Then I created the definition, as I just explained. Olama chat makes the API call with Olama that is available on your machine. We are passing the model, we are passing the message, and this definition is invoked here. So this step can be simplified. I can actually use it within the print statement. Print generate Docker file. Within the Docker file, I can use the language. Perfect. So let's go ahead and try to run it. Python 3 generate dockerfile.py. My expectation is that it should ask me to enter the programming language, because I shared it with developers. Let's say they should input programming language, and let's give, for example, Groovy. Let's see if it can print the Docker file for Groovy. In your case, again, I am repeating this. This might take even up to 10 minutes if you are using a low level configuration machine. And sometimes it might also respond back with connection timeout, or it might respond back with connection closure. All that because it is taking time. You might be running already few processes. In my case, I got response pretty fast where this is the Docker file. So what is it doing? It first included the base image as I asked, then it created work directory. Then I asked it to install dependencies, it did, asked to install the source code, it did, then set up some environment variables and run the application. If I have to, just to show you how simple is dealing with Gen AI, I can add one more constraint and say multi-stage Docker file or Docker build, right? So we can say multi-stage Docker build. Let's clear this and my bad. And let's run it. This time, let's provide another programming language. Let's provide, let's say Python itself. Let's see this time if it will generate the Docker file and make sure it uses the multi-stage Docker file. See, stage 1, stage 2. And in the stage 2, it used the Python slim image so that the image that is created or the Docker image that is created once you write the Docker file, run the Docker file, is small in size. Of course, you need to take this Docker image and make modifications according to your source code. But on a high level, what you learned is using generative AI, you can actually create the Docker images for programming languages sometimes you have not even heard about. So it doesn't matter in your organization if you're using Groovy, if you're using Python. As DevOps engineer, you're automating this experience for the developers. One final time, I'll show you with a complete different programming language, something that we might not be very familiar with, like Ruby on Rails. Let's see, this is the real test. Uh, to be honest, I have also never containerized a Ruby on Rails application, but my Docker file made it simple for me, or my Gen AI project made it simple for me. Perfect. So we are done with the first part. We are almost done with the project because the rest part is very simple. So we saw using local LLMs, how we can create this project. Now, Abhishek, I don't have a machine with enough resources. I'm trying this project, but it is taking a lot of time. Can I go with the hosted LLM approach? Yes, you can definitely go with hosted LLM approach if your laptop does not support the configuration. As I told you, most of the hosted LLMs, they charge you per API call, that is according to tokens. However, at this point of time, I noticed that Google AI Studio. So many of you know that Google is a competitor for OpenAI and they have their own model called Gemini. So there is a model called Gemini Pro, I think 1.5. And what Google right now offers is they offer a free API key. So you can create API key within Google AI Studio and you can use their Gemini Pro 1.5 and various other models that they support absolutely for free of cost. Now, it might be restricted for few users. It might be restricted according to the countries, which I cannot control for sure. Give it a try. Mostly it works for people who are in India, unless you have messed up with Google before or you have done something that Google does not like. Otherwise, you can just go to Google AI Studio and you can click on API key, get API key, and create API key, and Gemini API, and then let's say create API key in the current project. So it is generating the API key for me. You have to make sure the API key is secure, because otherwise somebody might use your API key. After doing this project, just better practice is to delete the API key. Okay, so you can just delete the API key so that you are done with it. And just like the local LLM, in the same repository, I have a folder for hosted LLMs that is using Gemini. If you go to this Python file, generate dockerfile Gemini. So of course the entire thing is exactly same. First you will import, just like how we imported Llama. This time we are not using Llama. So I'll import the Google generative AI. This is the package that we have to import. Abhishek, how do you know this? Very simple. Nobody knows this. You just have to go to the Gemini documentation or Google AI Studio documentation. And this is the standard thing that you import every time. And we are importing OS because I'm going to use the API key, right, this time. So we will just store the Google API key within this environment variable so that when the actual API call is made, it will fetch the API call from the operating system. Just like I'm declaring a variable, that's it. Okay, I'll put my API key here. I'll make sure to delete it once I'm done with this project. So I have my API key here. And then, I provided the prompt just like before. I created the definition and I invoked the definition that I created. So let's go back and try to run this program. Python 3. Now it's good that Google AI Studio is providing the free API key. Otherwise, we should go to OpenAI or same like Google AI Studio and create an API key which is chargeable. For every API key, depending upon the token, it is going to charge you. And charges, you can look at the particular website. For example, you can see OpenAI token cost. So OpenAI has the pricing where they tell you that if you are using 1 million token, it is going to charge you $15. And how do you know how much a prompt is consuming? Like if I give a prompt for the response as well as the request, how many tokens? How do you calculate that? In previous video, I showed you Google AI Studio does great job with it. Create Docker file for Java. So it will actually tell you the number of tokens. If you see here, right now the token count is 0. By the time my prompt is received and it responds back to me, it tells me that almost 1500 or 1600 tokens is consumed. So if we reach to a point of 1 million tokens, then OpenAI is going to charge me 15 US dollars if I use the O1 model. And if I use the O3 model, then it is saying that it is actually cheaper. For 1 million tokens, it is only going to charge 1.10 US dollars. So that is how you need to see. You need to be very careful when you're using the external models because somebody might perform a DOS attack, a developer who is a bad actor and might consume lot of or might incur a lot of costing for your organization. We'll also learn that in the future videos, how we can control that. We can do the rate limiting. We can, set up a limit on the OpenAI API keys. We will learn that step by step. So Python 3, generate Docker file, gemini.py. So it said no named module called Google. So what we need to do? Again, if you followed the previous one, we just need to go to this and we just need to copy pip3 install directly this, or we create a requirements.txt file. Within that requirement.txt, we just place this and we run pip install -r requirements.txt. Both are same. DAY-3 install. Let me do this. Now, once this package is installed, I can go ahead and run the program. Okay, so the package is downloaded. Now, let's retry it. Enter the programming language. Let's use Node.js this time. And you will notice the response that is generated from Google uh, large language model, that is Gemini, and from Llama, which we used for the local, is different because there are two different large language models, and the way of training those large language models or the data sets that is provided to it may be different. So that's why you will see the response different. But it doesn't matter. Usually for these kind of activities, uh, the response is quite commonly correct because dockerfile is a very common task. So most of the large language models, they provide accurate information in this case. However, when you are dealing with complex problems, that is where you have to decide which model you want to pick up. Do you want to pick up DeepSeek? Do you want to pick up Llama? Do you want to pick up Grenade from IBM or Gemini from Google? That's what you have to decide. Okay, so we got the Docker file, and just like what we did in the previous case, we can also do it here where add a multi-stage Docker build. In the constraints, I just added that. Again, let me provide Node.js to see if the constraint is received and if it can implement the constraint. Perfect. So this is the stage 2 and this is the stage 1. So this is how we can automate the Docker file generation using this GenAI project. I hope you enjoyed it and I hope you learned a lot with respect to Docker file generation and your very first GenAI project. If you have any questions, do let me know in the comment section. And please be patient if you are doing LLM setup on your local machine and if you're trying to get the output. If you have a CPU based architecture, it will take time. So please bear with it. Thank you so much for watching today's video. See you all in the next one. Take care. Bye bye.